by such a curve so that its slope is constant, and the only thing that is possible in the world where the slope is constant is an inclined straight line. So that everywhere if I take the slope, it is same. It cannot be parabola, it cannot be ellipse, so only straight line. Similarly, when I see between F and C, the shear force is constant. The bending moment here is 21.44 kilonewton meter. So it can join it again with the inclined straight line. Again the slope is constant, positive. So this is the correct BMD. Now lastly, going for part CD. Now we know that there is already reaction VD 7.14 and no horizontal reaction. Now let me calculate this angle first. So this angle will be tan theta is opposite by adjacent, that is 4 by 3. Therefore theta becomes 53.13. Now it is very simple that I will draw this line, I will draw this line, I will draw one line along this, and I will draw one line perpendicular to this. So now if this angle is 53.13, this opposite angle is 53.13, this angle is 90 minus 53.13, and again we know that alternatively this angle is 53.13, this angle is 90 minus 53.13, this angle is 90 minus 53.13, and again this is 53.13. Now before we start drawing AFD, SFD and BMD, let us start resolving this for 7.14. So when I resolve this 7.14 in this direction, it will be going in this direction, and its value will be 7.14 sine of 53.13, because we know the rule from engineering mechanics that whenever there is a force making an angle theta with a certain axis, and if you resolve that force along the same axis, it always becomes cos, whereas if you resolve it along the other axis, then it always becomes sine. So if you calculate 7.14 sine 53.13, it becomes 5.71 kilonewton in this direction. Similarly, when you resolve this force along this direction, since that force is making angle theta with that axis itself, obviously it becomes cos, and therefore when you resolve, it becomes 7.14 cos theta, which is 4.71 kilonewton. Now let me draw the simplified diagram of this. So to make it simple, I will again draw the free body diagram of element CD. This is 5.71 kilonewton. This is 4.71 kilonewton. Again we know a simple rule that if I consider this as x dash axis and this as y dash axis, 5.71 is going in upward direction. Therefore for summation of Fy dash to be 0, obviously the internal reactive force to be offered by part CBA to part CD at C must be equal and opposite to this. So 5.71 kilonewton. Similarly, if this is 4.71, here it must be 4.71 kilonewton. Again let me try drawing axial force diagram. So this is C and this is D. Now I know that this 5.71 and this 5.71, it is creating compression in this inclined member CD. So compression means I show it inside the frame. This is outside the frame and this is inside. So my sign convention, I show it inside. Again this 5.71 is same for the whole CD. So it is 5.71 kilonewton, 5.71 kilonewton. Just join it by a straight line, and since it is compression, I will take it as negative axial force diagram. Now coming to shear force diagram, again as I told you, we have to stand inside. So when I look, this becomes my left and this becomes my right. Now because of 4.71, left is going down. So when left is going down, that means it is negative, and I draw it inside. So it is 4.71 kilonewton. Again, if you observe, there is no any force between C and D, therefore shear force will remain same. Or in other words, even if you see directly the point D, because of 4.71 kilonewton, D is going up. So again, right up is negative. So either way, the answer will be same. So again, I will join it with a rectangle that is negative. So this is SFD. Now you don't have to take any extra effort to calculate bending moments, because it is obvious that from previous step already you know the bending moment at C and the bending moment at D, the roller end, is always 0 from our knowledge of strength of materials. So without wasting your time in calculation, directly you can draw a diagram for bending moment. That is, bending moment at D is 0 and bending moment at C, that was 21.44 kilonewton meter positive. So this C positive means I will show it outside the frame, 21.44 kilonewton meter, and since shear force is constant, bending moment will be an inclined straight line. So that is BMD. So that completes the problem for this statically determinate rigid jointed plane frame. Thank you.